Welcome to the video demonstration of the final prototype of the Pescado project. The project's goal is to combine environmental web resources, such as websites and services, into an intelligent decision support system based on semantic reasoning. The Pescado service can be used to support decisions related to environmental information like weather and air quality values. To achieve its goals, the system is separated into many services that form a coherent process to answer the user's inquiries, which can be seen in this overview. Prior to any user session, the system discovers potential web resources through a domain-specific targeted search and classification, and stores this information into a repository. When users access the system, they can formulate a problem description in a web-based editor and submit their inquiry to the system. There, the description is translated into semantic structures stored in the system knowledge base containing its domain knowledge. After identifying most relevant data providers, their data is merged and stored alongside the problem description. Due to the semantic descriptions of both data and problem, a reasoner can infer possible consequences for the users. In order to generate a final answer of the system, it discards obvious or irrelevant information from the knowledge base and reformulates the result to natural language text. The result is then shown to the user in combination with a visualization of the data. Many of the involved modules are parameterizable and can be targeted to individual users by incorporating their feedback. The end-user interface of the Pescado service is web-based and composed of a wizard dialog and, due to the geographic nature of environmental information, an underlying interactive map. The dialog guides the user through the process of describing their problem. Because the type of problems supported by the system is defined in its ontology, users can potentially generate invalid requests if their input contradicts the definitions used by the system. The user interface helps to avoid such incorrect queries by analyzing the ontology in combination with the user input, and highlighting or preventing problematic input. This can be seen by the red highlights and a red line, which points the user to the places where conflicting information was supplied. Prior to sending the request to the system, a short summary of the information shared with the service can be inspected. As this is a research prototype, the user management is only implemented in the user interface by generic default profiles. In this part, we want to have a look on how the Pescado system can be used. For this case, we have Fiona, one of our demonstration profiles, which describes a normal, medium-aged user with no special allergies or sensitivities. Suppose Fiona is planning her weekend activity near her hometown Espoo. From the welcome screen of the service, she goes to the Request tab to formulate her request. On the first page, she selects the nature of her problem from a list of available question types, such as instructions, reports, or warnings. She states that she is interested in being warned about potential health issues when she is undertaking her weekend activity. On the next page, she can specify this activity because different environmental aspects can be relevant. For instance, if one is doing heavy physical exercises, high ozone concentrations are more dangerous compared to when one is relaxing in the sun. In the latter case, high UV concentrations might be more dangerous. After selecting hiking as her activity, Fiona goes to the next page, where she can select the relevant region of her hike. While she is marking the area on the map, the wizard is minimized. Lastly, Fiona states the time frame of her activity, selects her user profile and submits the query. On the server side, different services are now working on the problem, from finding relevant data, merging the data, inferring consequences, rating relevances, until the answer in natural language is formulated. Once the result is received, the browser shows the resulting text containing the relevant information concerning her activity, alongside some views on the underlying data that were used to generate the response. The textual result is located in the wizard, where the underlying data is represented as a graph for temporal overview and concrete values in a separate area. Now Fiona could go back to the query form and adjust some parameters for follow-up questions, or if the result was not what she had intended. Users with more knowledge about the domain, for instance city administrations, use the same interface as casual users. Only the available question types and the formulation of the result may differ from the previous example. Here we already have formulated the basic parts of the request. We want Pescado to check the air quality in the Helsinki area and are now at an additional tab of the wizard with further export options. Among these options, we can choose to take control over the selection of relevant information and tell the system which kind of content we want in our result. On the server side, the workflow proceeds regularly but is interrupted at the step of selecting relevant content from the knowledge base. For this purpose, the system presents individual verbalizations of the knowledge base content that suffice to give the users an idea about the nature of the content units, but are not formulated as fluent as the final result text. Then, the users can accept or reject each content unit and submit their feedback to the system, where the remaining content units are re-ranked according to this feedback before presenting the next most important unit. After enough units have been reviewed, the system proceeds with the execution of the workflow and presents the final answer as usual. Our third use case covers multilinguality and the scheduling of recurring requests. Pescado's user interface and its text generation module are available in the three main languages of our domain partners. This is English, Finnish, and Swedish. We now switch the language to Finnish and again formulate a request stating the question type and area of our choice. In this case, we are interested in a recurring and detailed report on the air quality of the Helsinki area. Additionally, we provide parameters, for instance, on how frequent we want to receive the report, if we want to receive it only in the case of an actual warning, and by which means we want it. For the last parameter, we have the choice of email and public or private Twitter messages. We have now submitted our request and received a confirmation that it has been scheduled. At the specified time, we receive a message from the Pescado system that our report is available. Because of the limited size of Twitter messages, we follow the link to the actual result text.